Hi guys, welcome to Radioactivity Lesson 4. As always, we're going to start by looking at the answers from last lesson. Okay, here's the first slide. Now something to point out is where people tend to go wrong is they do not convert the minutes into seconds. Remember, time is measured in seconds in this instance. Okay, next slide. Okay, now today we're going to start off as always with some retrieval. Remember to pause the slides, make sure you've got something to write with, make sure you're filling any blanks in knowledge, filling those gaps in knowledge in. Okay, slide. Here's the answers. Second slide. Here's the answers. Third slide. And final. And here are our answers. Okay. Remember, a good thing to do is make revision cards for anything that we've not been able to retrieve. It's a really good resource, especially for next year. Okay, moving on to today's lessons. Now, this seems tricky to start off with, but once we've done some examples together and you've spent some time embedding this information, I promise you it's really very simple. Okay, we're going to be looking at how we undertake nuclear equations. First of all, as always, we need to get down some new knowledge. So make sure you've got a bit of pen and paper available. You can use a resource online or you can just write down questions just like I have. Okay, so new information. First of all, we're going to look at what happens to the mass and proton number during alpha decay. Okay, now during alpha decay, a helium atom is emitted. Okay, and let's remind ourselves that helium atom looks like this off our periodic table, 4-2. So therefore, if it's emitting a helium atom, that means the mass number decreases by 4. The proton number, the bottom number, decreases by 2. Okay, what happens to the mass of a proton, the mass and proton number, sorry, during beta decay? Now, people get a bit confused with this one. Now, we know a high energy electron is emitted. Now, during beta decay, a neutron turns into a proton and an electron. So, first of all, a neutron turns into a proton and electron. Now we know that the electron is emitted. What does that leave me with? That leaves me with a proton. So although it's emitting a negative electron, we have an extra proton now, which is obviously going to affect what our mass number and proton number say. So if I've got an extra proton, it's going to have an impact on the proton number. So the proton number increases by 1. Finally, what happens to the mass and proton number during gamma decay? Now, from our previous topic of waves, we know that gamma waves are part of the electromagnetic spectrum. So maybe I had to guess this one. The mass and proton number do not change. So they're unaffected. Right, Y underneath. Gamma decay is a wave. Remember, waves are how energy is transferred. And they do not contain any subatomic particles, such as protons, neutrons, and electrons. So pause the video and make sure you've got this down, please. As always, once you've got this down, we need to spend some time embedding this information. So once we've done that, I'd like you to spend some time embedding this new information. Okay, now moving on, we're going to have a look at some questions together. Now, these look really complicated, but they're really not. Okay, so first question says I've got an element which is Fr, and something happens to it. So this means something is emitted or decay is occurring. Okay, and the numbers have changed. So now I've got 207 and 85. Now, what did I say? What kind of radiation is going to cause 4 to be lost from the mass number and 2 to be lost from the proton number? Well, that's going to be alpha decay, and it releases, another clue here, is a helium atom. So even if I can't remember the numbers, I could look this up on my periodic table. 4, 2. Moving on. Here, this time, I can see again it's alpha decay because I've got a helium atom here. Now, but this time, I've got 233 here. I need to add on this helium atom because all this equation is saying it started off as this element, alpha decay has occurred and caused it to be this element, plus it has emitted the alpha decay, the helium atom. So we're going backwards this time. So I need to add 4 to 233. So 237 and add 2 to 91, which makes it 93. Okay. Moving on. Number 3. Now this time it's gone from 234 to 234. So it's not changed. It's gone from having a proton number of 90 to 91. So it's kind of gained a proton. So what does that mean I'm going to write? Nothing's happened at the top, but at the bottom it's emitted a negative electron. Okay, moving on. Number 4, again, this time it's emitted a negative electron. As before, this time again I'm working backwards. So is the top number affected? No. So that's going to be 6 still. The bottom number is emitted some beta decay and negative electron. Why? How does it do that? Because a neutron turns into a proton and electron. It hasn't emitted a proton, so therefore helium has gained an electron, gained a proton, sorry. There we go. Now, moving on. Number 5. This one is just an example to show you. We've got our element here. Starts at 234, mass number 90, proton number. But then it goes to 234 and 90 again. But something's happened here. That's what arrow is telling me. Something's happened. It's emitted some sort of radiation. And you can see here, this is the sign for gamma radiation. But as we know, when gamma radiation release doesn't contain any subatomic particles. So therefore, nothing has changed. Moving on to our final example, number 6. We've got helium to start off with. So there's been gamma radiations occurred. It's also giving me the element. The element here hasn't changed. Therefore, the proton number must be the same. So we've got 6 and 2. That is our final example. So pause the video, make sure you've got that down. And then what I'd like you to do is, following exactly the same format, undertake some independent practice. Now, the more you do of these, the more confident you will feel. Okay? So, independent practice. First slide. Second slide. Third slide. And our final slide. These are slightly more tricky, but still use the same process to work it out. Okay, and that is all for today. Thank you very much for listening, guys. It's still looking a bit miserable outside, unfortunately. Looking forward to some more sunshine soon, I hope. I hope you're all well and keeping safe. And I will speak to you next lesson. Thank you very much.